Hi, alright, in this video I'm going to talking about how to evaluate an integral, right? So how to evaluate an integral. So for example, this one is a definite integral. So where you have a limits, okay, bounded in a certain region. So we have to evaluate this integral here. So for this case, I specifically talk about definite integral that involving techniques of substitution. So for example, these cases you have learned previously that you have to choose a correct substitution function. So for example, this case I was choosing u to be x squared plus 1. Alright, u to be x squared plus 1 because so as you differentiate this du dx, so you were getting 2x, right? You were getting 2x, and of course your du will be your du, the 2 you can move over to one side and you have x dx here. The purposely of moving 2 and dx crossover is because I can see that I can rearrange this. Okay, I can rearrange this one, x squared plus 1 to the power of 3. X and dx, I can couple them together, so x dx. So then I can see that this can be replaced by du over 2, right? Where I involving substitution method, so du over 2. So now I'm going to replace this with du over 2. So of course that this also you have to replace with u, right? And the limit also must change while you're doing, because now it's different. It's integrate with respect to x, but after you convert it in term of u, it have to integrate with respect to u, right? So means that you have to integrate with respect to u. So as of the limits here, the value should change with u, the value of u. So now I'm going to replace. So let's look at this first, x dx. So I can replace as du over 2, okay, du over 2, and this one will be u to the power of 3, x squared plus 1, u, right, u to the power of 3. So of course the limit also must change. So how? So this is when the time x is 1. This is when x is 1. This is when the time x is 0, right? So when x is 1, so when x is 1, so what is the value of u correspond to this x equals to 1? So when x is 1, you refer to this. So means that you can convert your u as x is 1. So 1 to the power of 2 plus 1. So you have 2, right? So you can rewrite this as 2. When x is 1, u is 2, right? So now when x is 0, so when x is 0, your u will be 0 power of 2 plus with 1, right? So you're getting 1. So very simple. So when x is 0, you can change now, become u equals to 1. This is a proper way of doing substitution method for definite integral. Okay, so now you can very easily integrate because this is a very simple compared to this integrand. So 1 over 2, you can bring out the 1 over 2 and you integrate 1 to 2 for u to the power of 3 du. Alright, so then you integrate as usual, integrate u to the power of 3, you can integrate become u power 4 divided by 4 from 1 up to 2. Without replacing the u, without replacing the function x squared plus 1, you can evaluate by using the value of u here. Alright, so which will be equals to 2 times 4, 1 over 8 for u power 4 from 1 up to 2. Alright, 1 up to 2. So 1 over 8, 2 to the power 4, right? 2 to the power 4, subtract with 1 to the power 4. So which give you 16 minus 1, 15, right? 15 over 8. So then this will become your answer for this problem, the value here. So actually you can apply, you can using this calculator in helping you evaluate this, okay? So very simple. Then you can you see that this button here, so you key in this one, so you key in exactly what you have here. Alright, so you can key in 0, alright, 0, arrow go up, so you key in 1, so you have 0 up to 1, so go into the bracket, so you key in the function, the given function, so alphabet x bracket alphabet x square plus 1 shift to the power 3, okay? So you were getting this one, 0 to 1, x square plus 1 to the power of 3. So pressing the button equals, so you have 15 over 8. Can you see that? You were getting 15 over 8. So to perform techniques of substitution for a definite integral, this is the most appropriate way of doing. So let's move on with next examples. Alright, okay, let's move on with these examples. So, we also need using the technique of substitution. Okay, substitution. So, I'm going to apply u equals to 2x minus 1. Alright, or you can choosing u as a square root of everything. It's easier, right? It's much easier. So you can choose u as a square root of 2x minus 1. So I'm going to perform the integral. Alright, so how? I'm going to differentiate u equals to square root of 2x minus 1. So where before I differentiate, I make it become u square equals to 2x minus 1. Alright, u square equals to 2x minus 1. So I differentiate implicitly with respect to x. So it's 2u du dx. So and you're getting 2 here, right? 2x, you differentiate, you're getting 2, so divide both sides by 2, so you have u du, as the dx can cross over there, means that dx can replace by u du, right? Dx can replace by u du. So, and later, so I try to look at the integral here before, let's see, what can I replace here? So you can see that dx can replace as u du, right? For dx, you can replace as u du, and this whole thing you can replace with u, right? So how about x, right? So I have discussed before in the previous lesson during I discussed about indefinite integral. So as you can see that x, right? As long as you get all the information from here, all right, you can see that x can be related by using there's a relationship between x and u, right? So it means that u power of 2 plus 1 is 2x, right? U power of 2 plus 1 is 2x. So as I can see that x is u to the power of 2 plus 1 over 2, right? So I'm going to replace this whole thing into the function here. The x can replace with u to the power of 2 plus 1 over 2. So everything I convert become u. So, and the limits here, so there is a 5 and 1. It's much change, right? It's much change when you, now you are differentiate with respect to u, right? So of course the limits here, you should change. So how? So I'm going to look at 5, okay? When x is 5, when x is 5, when x is 1, so when x is 5, so when x is 5, you can substitute here. Alright, I can using this one because you want to get the value of u. So u will be square root of 2 times with 1 minus with 1. And for this you have u equals to square root of 2 multiplied with 5 minus with 1, right? When x is 5, right, 2, 5. So you have square root of 10. 10 minus 1, I have square root of 9. Eventually, you're getting 3. So, means that when x is 5, when you convert become u, everything in terms of u, so this one will become 3, right? So, whereas when x is 1, so when x is 1, so the value of u here will be square root of 2 minus 1, so you're getting 1. So, you are still getting 1 here, right? It's from 1 up to 3, right? I have changed the limit. So this is a appropriate way. This is the most important step here. So it's more appropriate if you're doing this. All right. So now I'm going to evaluate the integral. So can This one will be eliminated. And 1 over 2 you can take it out from the integral. So it's 1 to 3 u to the power of 2 plus 1 du. Right? And become a very simple integrand compared to this. Right? So then integrate u to the power of 3 divided by 3 plus with integrate 1, you're getting u from 1 up to 3. Alright? 1 over 2. So then you have to evaluate it slowly by substituting 1 over 2. Okay, what is the value? The value here, so you have 3 to the power of 3. Substitute 3 to the power of 3, right? 3 to the power of 3 divided by 3 plus 3. Everything, once you substitute for everything, 3, then you have to subtract 1, right? The 1 substitute, so you have 1 over 3, 1 to the power of 3 over 3 plus with 1, and you evaluate. So 1 over 2, so this will be 3 power of 2, so you have 9, 9 plus 3, 9 plus 3, you have 12, right? 12 minus with 1 over 3 plus 1, right? 1 over 3 plus 1, you have 4 over 3, 4 over 3. Okay, let's evaluate this. So 1 over 2 multiply into, you're getting 6, right? 6. So 12 divided by 2, you're getting 6. 4 over 3 divided by 2, you're getting 2 over 3. So finally, you have 3, 6, 18. 18 minus 2, you have 16 over 3 as your answer. Alright, so this is the way you evaluate the integral. So let's see, I'm still teaching you how to using this calculator. I very recommend that you learn how to using this. So okay, you can key in 1 arrow, go up 5, and the integrand. Alright, the integrand. Then you key in alphabet x square root 2x minus 1 to alphabet x minus 1. Alright, I have keyed in exactly what I get in here. So then I'm pressing the button equal. So I'm getting 16 over 3. Alright, you can, okay, but sometimes they give you decimal, right? 5.333. So if you're taking 16 over 3, if you take 16 divided by 3, you are still getting 5.333, okay? So means that you are getting 16 over 3. So, alright, I'm going to give you more examples. Alright, okay, let's look at these examples. So we are still using substitution method for these cases here. So you can try first choosing the right substitution function. So for these cases, we are choosing u equals to tangent x, as we know that you differentiate tangent, you are getting second square, which is here, right? Second square. So it's the choice is very important. So never mind, we try to differentiate first. So du dx. So if you differentiate, so differentiate tangent x, you will have second square x, right? Second square x. So you were having du equals to second square x dx. So you have getting something in the integrand here which can be replaced. So I rewrite this as 0 to pi over 3, and the tangents, I just write it to be power of 5. Alright, and second square, I couple it with dx. Alright, second square x dx, which can be replaced by du. So become a simple integrand. So once you replace everything with, we replace with du, everything have to in term of u. So du, right? Second square dx. And for this, you will have u to the power of 5. Wow, it's become a lot easier, right? Looks like very complicated, but now it's a lot easier. So become u to the power of 5 du. So, but don't forget that this is also must be substitute with a new value. So by refer to here, u is tangent x. So this is when the time x is 5, dx, so means from x equals to 0 up to x equals to pi over 3. So then I'm going to apply here, I have x equals to pi over 3. Then what is the value of u? So when x is 0, what is the value of u? So pi over 3 in radian, right? In radian. So if you're using calculator, make sure you are in radian mode. So pi over 3. So tangent pi over 3 is like tangent 60, right? Tangent 60. So it's a square root of 3. You are getting square root of 3 in these cases here. So and tangent u, x0, tangent 0. So you are getting 0. So means that in this evaluation here, you have from x to 0, x equals to 0, u equals to 0 up to square root of 3, right? When x is pi over 3, then your u will be square root of 3. When x is 0, your u is also 0. Okay, now you can integrate this u power of 5. U power of 5, if you integrate, you are getting u power of 6 divided by 6. So since I already convert the value here from x to u, so I have using this value, and I have no need to replace the u with tangent x, no need, because this is in term of u, right? So this is a value of u, so you can substitute. So it becomes square root of 3 power of 6 divided by 6 minus subtract with 0 to the power of 6 divided by 6. So then here you have 0. So square root of 3, right? Square root of 3 to the power of 6. Square root of 3 to the power of 6 is actually 3 to the power of 1 over 2 to the power of 6, right? So 2, 3, 6. So you will have 3 to the power of 3, 27. So I have 27 divided by 6 minus 0. So which can simplify, divided by 3. So you have 9 over 2, right? Or 4 to the half. So that's the answer for this problem. So you can using calculator to evaluate this, but you have to change your calculator mode into radian mode because you are evaluating integration involving trigonometry. So very simple, you shift setup, so choose the angle unit, so pressing the button 2, then you using the radian, right? Radian form, so you're choosing in radian. So now you can using this, so 0 to pi over 3, right? So you have shift, then you have pi over with 3, right? Over with 3. So 0 to pi over 3, can you see that? So then we move into the integrand. Right, so we key in second square. So second square is, there are no second function here. So you can using 1 over cos square. You can write in this form. So as tangent, okay, I have to put in bracket. So bracket, tangent, alphabet x, power of 5, right? Power of 5, tangent power of 5. As second square is 1 over cos square. So you can divide it by cos square. So cos alphabet x square, right? So this is equivalent. Then second square tangent power of 5 x dx. So we're pressing the button equal. So it takes some time for the calculator to calculate for this function, as it seems like complicated when involving trigonometry. Can you see that? You're getting 9 over 2, right? 9 over 2, which is 4.5, all right? Okay, That's all for this video. I will do more examples for the next video.